Good morning, all of you. So today we are going to discuss the new concept, new point under the topic DC circuit. Okay, so have attention towards that. So as we know that the definition of a DC circuit, we can define like that: a closed path followed by direct current. We call it a DC circuit. Is it right? This is the circuit diagram of a simple DC circuit. As we know that the three essential things are there to complete the DC circuit. Number one is a DC energy source. Number two is a load resistance, and number three is a connecting wires. Now, if I ask the question, how many load resistances are present in that simple circuit? My question is, in this circuit diagram, how many load resistances are present?
And
Only one. But if I have the more than one load resistances, means 2, 3, 10, 15, then how one can connect these load resistances to each other in the circuit? Based on that, the DC circuits are classified into three types. Once again, I will repeat my sentence. If more than one resistances are present, then how these resistances are connected to one another in the DC circuit? Based on that, the DC circuits are classified into three types. Number one, series DC circuit. Number two, parallel DC circuit. And number three, series parallel DC circuit is there. Means at least you have that idea based on what concept these three types are there, based on how the load resistances are connected to one another. It means that the simple thing is that if the resistances are connected in a series, forget about that, how they can connect it, what is the basic property. But if they are connected in a series, then this is called as a series DC circuit. If the load resistances are connected in parallel, definitely we can call it a parallel DC circuit. And if the resistances are connected either in series or in parallel or in a combination, then we call it a series parallel DC circuit. Is it right? And the same things we are now going to be discussed in detail is there. So let's we start to discuss about the series DC circuit is there. So the question it comes in your mind when we say that resistances are connected in a series, or how the resistances can be connected in a series, what are the properties of the series circuit, what are the application of series circuits. Definitely the answer of these all questions now you will get it through this discussion is there. So just have the concentration towards it. Now consider the three resistances. As I already said that if more than one resistances are connected to each other, based on that the DC circuit is classified. So here let me assume that the three resistances R1, R2, R3 and connected in a series across a battery of V volt. But when we say that these resistors are connected in series, let's consider that R1. This is a first resistor, we call it a R1 value. Is it right? When I say that the resistor, definitely it has its two terminal. Just consider that this is the first terminal and this is the second terminal. Now the point is that when the resistances are connected end to end, when resistances are connected end to end means what? It means that one end of R1 is connected to one end of a R2. Now if you see that in between this R1 and R2, here the one common point is there, and the important thing is that this common point is not connected to any another branch. That's why we say that R1 is connected to the R2, means that resistances are connected end to end. Again, if I consider that resistor R3, now the one terminal of R2 is connected to one terminal of R3 is there. Is it right? It means that very important thing is that when the resistances are connected end to end, it means that one end of resistor is connected to one end of another resistor, and there is a one common point in between the any two resistor. Now if you see that R1 and R2, this is a common point, and this common point is not connected to any another branch. This is the mandatory condition to say these resistors are connected in a series. Now if you see in this connection, R1 and R2 is connected to one common point and is not connected to any another branch. R2 and R3 is connected to one common point and it is not connected to any another branch. That's why there is only one path to the flow of current in between all these three resistances. Then we say that these three resistances are connected in series. And now here, out of this series DC circuit, now this is a series circuit. R1, R2, R3 are connected in series. Now again, these are the two end terminals of this series circuit. Is it right? And when these two end terminals are connected to the DC source, then this entire circuit is called as series DC circuit. Let me clear these things. The series part is different, DC circuit is different. So these resistors R1 and R2 are connected in end to end, so that there is only one path to the flow of current, and these series combination of resistances are connected across a battery of V volt. Then this entire circuit, we call it a series DC circuit is there. If you have that any doubt, please raise that doubt is there related to the series circuit is there. But the two things are very important. What are these two things? When we say that resistance R1, R2 and R3 are connected in series, the first thing is that they are connected end to end. Now here the R1, R2 are connected in end to end. And second thing is that in between two resistors, there must be a common point, and this common point is not connected to any another branch. आता तुम्ही इथं जर बघितलं, R1 आणि R2 मध्ये एक कॉमन पॉइंट आहे. तो कॉमन पॉइंट दुसरा कुठल्या ब्रांचला कनेक्ट आहे का? नाही. R2 आणि R3 मध्ये पण एक कॉमन पॉइंट आहे. तो कॉमन पॉइंट पुन्हा कुठल्या वेगळ्या ब्रांचला कनेक्ट आहे का? नाही. इट मीन्स दॅट दे आर कनेक्टेड एंड टू एंड, सो दॅट देर इज ओनली वन पार्ट टू द फ्लो ऑफ करंट. आता करंटची डायरेक्शन बघा काय आहे ते. ॲज वी नो दॅट करंट इज ऑलवेज start its journey from positive terminal. Now suppose I consider that I current, it starts from the positive terminal of a battery V. Now when I current, it starts from positive terminal of a battery V, it comes to this point. Is it right? And definitely when it flows through R1, when it flows through that R1, it comes to that common point is that. Now for this current, there is only one path to the flow of current to flow through that R2. There is no any another path to the flow of current. It means that what value of current flowing through that R1, same value of a current it flows through that R2. When it flows through that R2, it comes to this same common point. What value of current flowing through that R1 and R2, same current will flow through that R3 also, and definitely it return to the negative terminal here. But when we say that current flowing through that R1, when the current is flow through that R1, according to that Ohm's law, definitely voltage is developed across that R1. Let's we consider that voltage developed across that R1 is V1. Due to what? Current flowing through that R1. If the current flowing through that resistance is absent, is the voltage is developed across it? No, because according to that Ohm's law, when the current is flowing through that R1, in between the two terminal of R1, definitely a voltage is developed. Now here we assume that voltage developed across that R1 is V1. Again, voltage developed across that R2 is V2. Again, voltage developed across that R3 is V3, and then current will return towards the negative terminal. As I already told you, the basic property of a current, what value of current it starts from positive terminal of a battery, same amount of current should return to the negative terminal of a battery. It means that if you see in this circuit, there is only one path to the flow of current. That's why we call it as a series DC circuit is there. That's why we call it a series DC circuit. But if you observe the thing here, in the series DC circuit, what is the current flowing through that R1? It's I ampere. What is the current flowing through that R2? Again, it's I ampere. What is the current flowing through that R3? Again, it's I ampere. Means, can I say that here I ampere of a current, it flows through R1, R2, R3. So we can make a conclusion like that. We can do the conclusion like that. The current flowing through the series resistance is the same. Current flowing through the series resistance is the same. But due to this current, the voltage is developed across each series resistance according to that Ohm's law. And this developed voltage, it may be different. It based on the resistance of that resistor. Is it right? It based on the resistance of that resistor. It means that if the value of resistance is more, definitely the more voltage is developed. But if you think about it, so this applied voltage of V volt is connected in between the two end terminal of a series combination. And we know that this applied voltage will make the potential difference between these 2 points A and B. Let me consider that. It means that this applied voltage will not appear across this R1 only, will not appear across that R2 only. So the voltage in the series circuit is divided. This total voltage in series, because how much is the total voltage in between the point A and B? It's a V volt. But if we see that the voltage across that R1 is V1, voltage across that R2 is V2, voltage across that R3 is V3, means can I say that if you do the summation of all these three voltages, can I say that this is equal to the total voltage V? Yes or no? Means I say that V is equal to V1 plus V2 plus V3 is there. Get it my point? So
Yes.
in this way, we can say about the series circuit. Now see that the statement of the series circuit is there. A DC circuit in which resistances are connected end to end, so that there is only one path for current to flow is called series DC circuit. See that. Hope that these concepts about the series DC circuits will be clear to you. So for that, once again repeat, I will repeat. Number one, the resistances are connected end to end. There is a common point in between the two resistors, and this common point is not connected to any another branch. And there is only one path to the flow of electric current. Then we say that it is a series DC circuit is there. Is clear? Now let me go to that next slide. See that animation of a series DC circuit. Here if you see that the current always starts its journey from positive terminal, it flows through R1, R2, R3, and then it come back to the negative terminal of an external battery. Is it right? And due to that current, when the current it flows through that R1, some voltage is developed. We assume that it's a V1. When the current it flows through that R2, again some voltage is developed. We call it a V2. Again, when the current is flowing through that R3, definitely the certain voltage is developed. We call it a V3. But if you see that this total voltage is appear or it is applied to the complete series circuit. so that we call the V1 plus V2 plus V3 is equal to the applied voltage, but the current flowing through all these three resistances is the same. Get it my point? Okay. Now, if you see that this R1, R2, R3 are connected in series across a battery of V volt, and because of that, I ampere of current it flows through the circuit. Due to that I, voltage across R1 is V1, voltage across R2 is V2, and voltage across R3 is V3, and again current it comes back to the negative terminal. Now, if you see this diagram very clearly, then we can easily say that the current flowing through these three resistances is same, and that is nothing but I ampere. If you have the value of I, if you know the resistance of that resistor, by applying that Ohm's law, we can easily calculate that voltage across resistor R1, we assume as a V1, which is nothing but apply Ohm's law I into R. But the resistance of that resistor is what? It's a R1. So we can say that V1 is equal to I into R1. Similarly, voltage across that resistor R2, we assume that it's a V2, which is equal to I into R2. And voltage across that resistor R3, we assume that it's a V3, which is equal to I into R3. It is just Ohm's law. Now, how I have not written here I1, I2, I3, because we know that the current is same for all the resistances. Then why it is necessary to write it down? But the voltage developed across that resistors is different. It depends upon that resistance. Are you getting my point? So in this way, if you see this formulae, in this way, by applying that Ohm's law, we can easily calculate the voltage drop across each series resistance. Is it right? Now, let me go to that next point again. Okay. So this is our same circuit. We know that V1 is equal to I into R1, V2 is equal to I into R2, and V3 is equal to I into R3. And we know that this V is our total applied voltage, which is always equal to voltage drop across each series resistance or individual resistance is there. That's why I have written, I can write that equation for applied voltage is equal to V1 plus V2 plus V3. Now let me try to put that value of V1 is nothing but IR1 plus value of V2 is nothing but IR2 plus value of V3 is nothing but IR3. Now in this case, I is a common, let me take it outside, so that in a bracket what is remain? R1 plus R2 plus R3. Now when I transfer this I to the left hand side, it should be divided to that applied voltage. So on the left hand side, the ratio it becomes voltage, total voltage or applied voltage divided by total current is equal to R1 plus R2 plus R3. But what the ratio which is present at the left hand side of this equation, that is nothing but V upon I, what it represents? What it represents?
Resistance.
It is the total resistance of the series circuit. Is it right? So here I say that where V divided by I is the total resistance of a series circuit, and it can be represented by equivalent resistance or total resistance or series resistance. So you have see that how which types of symbol we can use to represent the total resistance of a series circuit. Is it right? So I can write V upon I, which is equal to total resistance, which is equal to R1 plus R2 plus R3. So from this equation, can I make the sentence like that? The total resistance of a series circuit is always equal to sum of individual resistance of that circuit. Yes or no?
Yes, sir.
Absolutely correct. Now it's your turn is there. Can you pick up? I have explained all the characteristics of a series DC circuit in my explanation is there. Now it's your duty. Can you pick up one by one main characteristics of a series circuit and can you share with all? Yes, please. Don't worry about it. If you do the mistakes, no one will laugh on it, and I am here to correct you. Definitely, I will appreciate your efforts. Give me that one by one characteristics of a series circuit through this discussion. Yes, please. Anything?
The current flowing through each resistance is same.
Absolutely correct. This is the
Uh,
first. Okay, you want to say something again?
there is one common point between two resistances, which is not connected to other branches.
Okay. Anything else? Or what?
And voltage is different for R1, R2, and R3.
Voltage is different for different resistors. Okay. Means the three characteristics here she has put it in front of all. Out of that, the one characteristics is current flowing through series resistor is the same. This is the first one. Second thing, the voltage across each resistance is depends upon that resistor, or we say that it's a different. Is it right? So better way, in place of that sentence, I can write the sentence like that: the total voltage is equal to the sum of voltage drop across each resistance. Means V is equal to V1 plus V2 plus V3. This is the second the characteristic is there. And the third thing is that the resistances are connected end to end. Actually, this is the definition of a series circuit. Get it, my point? Anybody else? I think one characteristic is in front of you. Can anybody try to make the sentence?
The sum of individual resistance is equal to total resistance.
Absolutely correct. The total resistance of a series circuit is always equal to sum of individual resistance of that circuit. And if here we have just seen the resistance R1, R2, and R3. And what is this? This is the external battery. And that practically, that external battery is also having its own internal resistance. And we learn in the real voltage source, it has its internal resistance. And if we consider this internal resistance in this case, so what is the equation for the total resistance of a series circuit? So R total, which is equal to R1 plus R2 plus R3, and again I can write here plus internal resistance of a battery. If we want to consider it, जर ती आपल्याला कन्सिडर करायची असेल किंवा आपल्याला ती माहित असेल, then we can add it in between R1 plus R2 plus R3 plus R internal, which is equal to R total. परंतु हा जो काय पार्ट आहे, जो जर माहित असेल तर तो आपण ऍड करू शकतो, otherwise not. That's why I have not written here. Is it right? Okay. So now see that what are the characteristics of a series circuit here. Let me go to that one by one characteristics. Number one, current in each resistor is the same. Number two, total resistance of a circuit is equal to sum of individual resistance plus internal resistance of a cell. Cell म्हणजे battery, if any. त्याच्यासाठी पण मी लिहिलेलं तिथं if any. Number three, voltage drop across any resistor is directly proportional to the resistance of that resistor. आता आपल्याला माहित आहे, we have assumed that voltage drop across that R1 is V1, voltage drop across resistor R2 is V2. Now, if I want to write that equation, can I write it down here? V1 is equal to I into R1. But what about this I? I is same for all the resistors. It means that it is a constant, it is the same. So can I say that V1 is directly proportional to R1? Yes or no? Yes or no?
Yes, sir.
It means that this is the third characteristic, because we know that in the series circuit current is always same. So we can say that the voltage drop across any resistor is directly proportional to the resistance of that resistor. मला वाटतं मी explanation मध्ये सुद्धा ते explain केलेलं आहे. If the value of R is a greater, then definitely voltage drop across it is also having its more value. If value of resistance is small, the voltage drop is also the less is there, because it's a constant. That's why I have written that the third main characteristics, the voltage drop across any resistor is directly proportional to the resistance of that resistor. Are you clear about it? Is it clear? Yes or no?
Yes, sir.
Okay. Now go to that next. The total resistance of a circuit. बघा आता चौथी property व्यवस्थित वाचा. The total resistance of the circuit is always more than the largest resistance of that circuit. Let me try to explain. Suppose if I consider that R1 is 2 ohm, R2 is of 3 ohm, and R3 is of 4 ohm. So if and these three resistances are connected in series, so can I say that R total, which is equal to R1 plus R2 plus R3. What is that value? 4 plus 3 plus 2.
9.
It's a 9 ohm. And what the sentence
9.
I have written here, the total resistance means this 9 ohm of the circuit is always more than largest resistance in that circuit. आता largest resistance कोणता आहे हो इथं?
4 ohm.
It's a 4 ohm. Is it right? So here I say that this 9 ohm is always greater than 4 ohm कारण आपण इथं addition करतोय. मग addition करतोय म्हटल्यानंतर definitely addition ही त्या number पेक्षा जास्तच असणार आहे. It means that you have to take care that the total resistance of a series circuit is always greater than the largest resistance present in that circuit. This is another one main characteristic. Get it my point? Okay. Then the last one characteristic is the applied voltage is equal to sum of voltage drop across each resistances. It means that V is equal to V1 plus V2 plus V3. These are the main characteristics of series circuit. Get it my point? Okay. If you have that any doubt, you can ask. Otherwise, I will go to the next slide. Now see that application of series DC circuit. आता इथं matter काय लिहिलेलं आहे? Please don't try to see these things. What I am going to discuss, try to listen very carefully and see on that screen is there. Now we want to learn that what are the application of a series circuit is there. Now let's assume that this is a LED. Do you know that LED? What is the long form of that LED? Light emitting diode. Light emitting diode. Is it right? Now we know that this light emitting diode म्हणजे आपण घरामध्ये डेकोरेशन साठी यूज करतो किंवा लाईट इंडिकेटर म्हणून ते यूज केले जातात. बरोबर आहे. आजकाल आपली मोबाईलची स्क्रीन सुद्धा एलईडी येऊ लागलेली आहे. त्यानंतर टेलिव्हिजन एलईडी येऊ लागलेला आहे. बल्ब एलईडी येऊ लागले आहेत. मीन्स एव्हरीथिंग इट कम अप विथ the new technology is come up with the LED here. Is it right? Now this LED is required 1.6 volt to glow. म्हणजे त्याला किती व्होल्टेज लागतंय? 1.6 volt and 15 milliampere current flowing through it. That time it will glow. And the specification, it means that this is the specification of a LED. म्हणजे LED ला जर आपल्याला ग्लो करायचं असेल तर त्याला आपल्याला 1.6 volt द्यावं लागतं आणि 15 milliampere current द्यावा लागतो. But now when I connect this LED to the DC circuit of a 5 volt, my question is that will this circuit it works? हे सर्किट वर्क होईल का हो? Yes or no? काही पण आन्सर असू द्या. मला वाटतं तुम्ही रिस्पॉन्स द्यायलाच फक्त कमी पडताय बघा. मला रिस्पॉन्सच लवकर मिळत नाही. एक तर येस तरी म्हणा किंवा नो तरी म्हणा. तुम्हाला कोण चुकीचं आन्सर दिलंय म्हणून कोण पनिशमेंट द्यायला येणार नाहीये. गेट इट माय पॉइंट? ऍटलीस्ट आय गॉट द थिंग्स. यू आर अप टू व्हॉट लेवल. फक्त तेवढंच मला लक्षात येणार आहे आणि त्याच्यानुसार मग माझं एक्सप्लेनेशन एकतर वाढेल किंवा कमी होईल. इज इट राईट? But if you just kept mum, means you decided to not speak any single word, then it's quite difficult for me, because it's quite difficult to understand what is exactly happening. Is this circuit, it works or not? Okay, माझा आता सिंपल प्रश्न आहे, am I audible?
Yes, sir.
Yes, sir.
ओके, म्हणजे ऍटलिस्ट तुम्ही ऐकताय तरी ठीक आहे, काय हरकत नाही, मीच आन्सर देतो आता याचा. दिस सर्किट इट विल नॉट वर्क एट ऑल. ऍक्च्युली द सर्किट, दिस एलईडी विल बी बर्न. आता एलईडी बर्न का होतं ते पहिल्यांदा बघा. हाऊ मच व्होल्टेज इज रिक्वायर्ड टू ग्लो दॅट एलईडी? इट्स 1.6 व्होल्ट. आणि हाऊ मच व्होल्टेज वी हॅव गिवन टू दॅट एलईडी? इट्स 5 व्होल्ट. मग आता एलईडी सांगा मला, एलईडी ला ग्लो होण्यासाठी फक्त 1.6 व्होल्ट लागतंय आणि आपण देताना त्याला दिले 5 व्होल्ट. इट्स फार ग्रेटर दॅन 1.6 व्होल्ट. डेफिनेटली एलईडी विल बी बर्न. बरोबर आहे. मग आता हे सर्किट तर वर्क होत नाहीये, इथं एलईडी तर बर्न होतोय. मग आता आपल्याला हे सर्किट वर्क कसं करायचं? कारण आपल्याकडे तर सोर्स आहे 5 व्होल्टच आणि एलईडी तर आपल्याला ग्लो करायचा आहे. देन यू कॅन अप्लाय द कन्सेप्ट ऑफ अ सिरीज सर्किट हियर. Then you can apply the application of a series DC circuit here. कारण आपल्याला सिरीज डीसी सर्किट मध्ये काय सांगतं, हे म्हणजे 5 व्होल्ट म्हणजे काय, टोटल व्होल्टेज, आणि हे 1.6 म्हणजे काय, एक V1 कन्सिडर करा किंवा V2 कन्सिडर करा. मग अप्लाइड व्होल्टेज इज ऑलवेज इक्वल टू द व्होल्टेज ड्रॉप अक्रॉस इच रेजिस्टन्स. म्हणजे इथं 5 व्होल्ट, मग ह्या एलईडी ला गेलं टोटल व्होल्टेज 5 व्होल्ट गेलं. मग जर आपल्याला हा एलईडी वर्क करायचा असेल तर त्या एलईडीच्या सिरीज मध्ये जर आपण एक असा रेजिस्टन्स कनेक्ट केला की जेणेकरून एलईडी ला फक्त 1.6 व्होल्टच जाईल आणि जो काही डिफरन्स आहे 5 मायनस 1.6 म्हणजे 3.4 व्होल्ट, तो त्या सिरीज रेजिस्टरच्या अक्रॉस जाईल. दिस इज द ऍप्लिकेशन ऑफ सिरीज रेजिस्टर हियर. नाउ दिस इज अ सिरीज रेजिस्टर. वी डोंट नो दॅट व्हॅल्यू, but we say that it's a R ohm. So definitely how much is how much expected voltage drop across that R ohm? It's a 3.4 volt. मग आता या R ohm च्या अक्रॉस जर 3.4 व्होल्ट गेलं तर एलईडी ला किती मिळेल व्होल्टेज? 1.6 मिळेल. बरोबर आहे. म्हणजे आपलं एलईडी चे जे स्पेसिफिकेशन आहे ते आपण फुलफिल करायला चालू केलेले आहे. तशी एक स्पेसिफिकेशन फुलफिल केलंय की एलईडी ला 1.6 व्होल्ट लावले दिलेलं गेलेलं आहे. म्हणजे इथं सिरीज रेजिस्टन्स ऍप्लिकेशन आहे. डू यू अंडरस्टँड दिस थिंग्स? इट मीन्स दॅट द व्होल्टेज अक्रॉस द सिरीज रेजिस्टन्स इट्स अ 3.4 व्होल्ट. आता एलईडी ला ग्लो होण्यासाठी करंट किती लागतोय? 15 मिली एम्पियर. मग आता रेजिस्टन्स हा सिरीज मध्ये कनेक्ट केलेला आहे, म्हणजे त्यामधून पण किती करंट फ्लो झाला पाहिजे? 15 मिली एम्पियर. कारण आपल्याला सिरीज सर्किटची प्रॉपर्टी सांगते, जर हे आर आणि एलईडी जर सिरीज मध्ये असतील तर त्यातून फ्लो होणारा करंट हा सेमच असला पाहिजे. म्हणजे आपल्याला आर मधून सुद्धा 15 मिली एम्पियर करंटच फ्लो होऊ दिला गेला पाहिजे. म्हणजे टोटल सर्किट करंट हा 15 मिली एम्पियरच झाला पाहिजे. म्हणजे आर मधून फ्लो होणारा करंट हा 15 मिली एम्पियरच असेल आणि त्याच्या अक्रॉस जर व्होल्टेज हे 3.4 व्होल्ट असेल तर त्या आर ची व्हॅल्यू आपण ओहम्स लॉ न अप्लाय करू, कॅल्क्युलेट करू शकतो. बघा कशी कॅल्क्युलेट केली व्हॅल्यू. आर इज इक्वल टू व्ही डिवायडेड बाय आय. आता हे व्ही म्हणजे टोटल व्होल्टेज नाहीये, या रेजिस्टर आर च्या अक्रॉसचं व्होल्टेज आणि ते आहे 3.4 व्होल्ट डिवायडेड बाय टोटल करंट 15 मिली एम्पियर. Means this much value it must be connected in series with this LED in this circuit. That time only this circuit it will work. बघा आपण फक्त ओहम्स लॉ आणि सिरीज सर्किटच्या माध्यमातून फक्त त्याचं ऍप्लिकेशन कन्सिडर करून आपण हे कंप्लीट सर्किट डिझाइन केलेलं आहे. म्हणजे एक एलईडी, त्याचं तर स्पेसिफिकेशन फिक्स आहे 1.6 व्होल्ट 15 मिली एम्पियर. 5 व्होल्टचं सप्लाय आपल्याकडे आहे असं कन्सिडर करू. एक बॅटरी आहे 5 व्होल्ट असं कन्सिडर करूया. मग हे जर सर्किट वर्क होण्यासाठी आपल्याला अप्लाय करावा लागतोय सिरीज रेजिस्टरचा कन्सेप्ट, सिरीज डीसी सर्किटचा कन्सेप्ट. अँड दिस इज द वन ऑफ द ऍप्लिकेशन इज दॅट. गेट इट माय पॉइंट? ओके, सो नाउ यू कॅन रीड इट. येस प्लीज. You can read it. Figure shows that LED circuit. The desired brightness of a LED occurs when LED current is 15 milliampere and the voltage across it is 1.6 volt. So it is necessary to use the series resistance to satisfy the LED specification. So the voltage across R, we can calculate 5 minus 1.6, which is equal to 3.4 volt, and the value of R, which is equal to Ohm's law V divided by I, which is equal to 3.4 divided by 15 milliampere, which is becomes 227 ohm. This is the one of the application. मग आता तुम्ही असं म्हणसाल की असं कितीतरी सर्किट्स आहेत त्याच्यामध्ये आपल्याला सेरीज सर्किट. Yes, whenever you will observe the any electrical and electronic circuit, definitely where the series and parallel circuit concepts are, or these are the application of a series and parallel circuit. कारण तुम्ही कुठलंही सर्किट घ्या, any circuit, that is the application of series and parallel circuit. That's why I say that this concept is very, very important. Without this concept, you will not understand that electrical and that electronics engineering is there. Get it, my point? So this is the one of that application. I will try to explain another one application. Just concentrate towards that the next point. It's a second application. आता इथं तुम्ही असं कन्सिडर करा, दिस वन इज अ वन डीसी मोटर. डीसी मोटर मला माहिती आहे, सगळ्यांना माहित असेल, गणपतीला पाठीमाग जे आपण फिरवतो ना, ते सर्कल चक्र म्हणतो आपण त्याला, त्याच्यासाठी डीसी मोटर यूज केलेली आहे. म्हणजे भरपूर कारणासाठी आपण डीसी, आपल्या जे लहान मुलांचे जे खेळणी असतात, त्या खेळणीमध्ये जे पळणारी जी खेळणी असतात, मुव्हेबल जी टॉयज असतात, त्याच्यामध्ये डीसी मोटर्स आहेत. बरोबर आहे. नाउ this is a DC motor. This is DC energy source, and we have to control the speed of a DC motor. आता त्या स्पीड, डीसी मोटरचा जर स्पीड कंट्रोल करायचा असेल तर I use that one series resistance. आता तुम्ही म्हणताल की हा वेगळा सिम्बॉल दिसतोय इथे, एरो काय करतोय? हा एक थोडा वेगळ्या टाइपचा सेरीज रेजिस्टन्स आहे, ज्याला म्हणलं जाते व्हेरिएबल रेजिस्टन्स. मला वाटतंय तुम्ही दोन नाव ऐकले असतील, एक तर रिओस्टॅट, प्रॅक्टिकलला यूज केलं असेल, किंवा पोटेन्शियोमीटर. तर तो हा प्रकार आहे से व्हेरिएबल रेजिस्टर. वी कॉल इट रिओस्टॅट और पोटेन्शियोमीटर. मला वाटतं फिजिक्स मध्ये तुम्ही रेजिस्टन्स व्हॅरी करण्यासाठी रिओस्टॅट वापरला असेल. इज इट राईट? नाउ इफ वी वॉन्ट टू have a control on the speed of this DC motor. आता त्या स्पीड वरती कंट्रोल करायचा आहे, म्हणजे कशावरती कंट्रोल करायचा आहे? करंट वरती कंट्रोल करायचा आहे. जसं की आपल्या घरामध्ये आपण फॅन वापरतो, त्या फॅन साठी एक रेग्युलेटर आहे, तो रेग्युलेटर म्हणजेच एक पोटेन्शियोमीटर आहे. तो जर तो ओपन करून बघितला तर तोच हा व्हेरिएबल रेजिस्टर आहे. म्हणजे आपण तो जो रेग्युलेटर आहे तो 1 वरती केला तर फॅनचं स्पीड मिनिमम असतंय, 2 वरती केला तर फॅनचं स्पीड इन्क्रीज होतंय, 3 वरती केला की अजून थोडं इन्क्रीज होतंय. इज इट राईट? म्हणजे त्यातून फ्लो, त्याला सप्लाय होणारा करंट ऍक्च्युअली आपण कंट्रोल करतोय सिरीज रेजिस्टरच्या माध्यमातून. दिस इज अनदर वन ऍप्लिकेशन इज दॅट. दिस इज ऑल्सो यू कॅन कन्सिडर इन प्लेस ऑफ मोटर, यू कॅन कन्सिडर दॅट इट्स अ फॅन. पण तो फॅन हा एसी डिव्हाइस झालाय. आपण इथं डीसी सर्किटच्या बाबतीमध्ये बोलतोय, त्यामुळे मी इथं डीसी मोटर म्हणलेलं आहे. बरोबर आहे. जर या मोटरचं स्पीड जर आपल्याला कंट्रोल करायचं असेल किंवा मिनिमम किंवा मॅक्सिमम करायचं असेल तर डेफिनेटली आपल्याला एक सेरीज व्हेरिएबल रेजिस्टर कनेक्ट करावं लागेल. ही पण एक सेरीज सर्किटच ऍप्लिकेशन आहे, कारण इथं जो काय रेजिस्टन्स कनेक्ट केलेला आहे दॅट इज कनेक्टेड इन सेरीज विथ दिस मोटर. आता मी ते सेरीजच का म्हणलं तर यू कॅन सी दॅट अप्लाय दॅट कन्सेप्ट. one terminal of this resistor is connected to the one terminal of a motor, and this common point is not connected to any another branch. Then we can easily say that this R and motor are connected in a series. तसंच तुम्ही पाठीमागच्या डायग्राम मध्ये सुद्धा तुम्ही बघू शकता. Why we say that this R and LED are connected in series? Because one terminal of R, this one, is connected to the one terminal of a LED, and this common point is not connected to any another branch, so that there is only one path to the flow of a current. That's why we call they are connected in a series. And this series combination is connected across a battery of V volt. Similarly, now you can just see that here these variable resistor and motor are connected in a series, and this series combination is connected across a battery of V volt. Is it right? It means that This is also a one application of a series resistor here. मग आता when I put the value of this variable resistor is a maximum. आता एक लक्षात घ्या, जर त्या व्हेरिएबल रेजिस्टरची व्हॅल्यू मॅक्सिमम आहे म्हणजे त्यातून फ्लो होणारा करंट काय असेल, मिनिमम असेल. मग तो करंट जर मिनिमम असेल तर या मोटरचं स्पीड काय असेल, डेफिनेटली मिनिमम असेल. इफ आय सेट दिस व्हेरिएबल रेजिस्टर ऍट इट्स मिनिमम व्हॅल्यू, म्हणजे रेजिस्टरची व्हॅल्यू जर आपण मिनिममला सेट केली तर डेफिनेटली मॅक्सिमम करंट फ्लो होईल. जर मॅक्सिमम करंट आर मधून फ्लो झाला म्हणजे सेम करंट मोटर मधून पण फ्लो झाला. मग जर सेम करंट मोटर मधून फ्लो होत असेल तर त्या मोटरचं स्पीड सुद्धा काय असेल, मॅक्सिममच असेल. इन दिस वे वी कॅन से दिस इज अ सिंपल वन सर्किट. जस्ट आय वॉन्ट टू bring in your notice is that what are the application of a series resistor. म्हणजे आपल्याला बाकीच्या सर्किट बद्दल जास्त काही बोलायचं नाही, फक्त आपल्याला जे बोलायचं ते series resistor. These are the application. I just put it two application in front of you only. But as I say that whenever you will observe that any electrical and electronic circuit, over there the series and parallel circuit concepts are used. Read it. रिओस्टॅट आर, आता त्याला मी रिओस्टॅट म्हणलेलं आहे, तुम्ही पोटेन्शियोमीटर म्हणा, व्हेरिएबल रेजिस्टर म्हणा. अ रिओस्टॅट आर इज यूज्ड टू ऍडजस्ट द स्पीड ऑफ अ मोटर. व्हेन आर इज अ सेट at maximum position, the current is minimum and the motor speed is also minimum, and vice versa. This is the another one application of a series circuit is there. Are you clear my point? Okay, so today okay, still we have the time. Now we discussed that the main characteristics, we discussed that the application of a DC circuit. Now what are the limitations of a series DC circuit is there? If you think like that there is no limitation of a series circuit, then why the parallel DC circuit comes into existence? माझा प्रश्न असा आहे की series circuit चे काहीतरी लिमिटेशन असले पाहिजे, त्यामुळे तर parallel DC circuit हा concept डेव्हलप केला गेलेला आहे. Get it my point? So let's we have the discussion about the limitations of the series DC circuit is there. So the first limitation is that if a break occur in any part of the circuit, no current flow through the entire circuit and entire circuit becomes useless. आता त्याच्यासाठी मी एक एक्झाम्पल देतो बघा. आता ते एक्झाम्पल कसं असेल बघा. जस्ट कन्सिडर दॅट this is a resistor R1, this is a resistor R2, and this is a resistor R3. How they are connected? They are connected in series across a battery of V volt. It's right. Now we know that this is a closed path, so definitely current it can flow through the circuit and circuit it works. But due to the some problem, if we assume that R2 is get open, R2 is get open, it means that here if you see that the open is developed. Now my question is that is the current will flow through the circuit?
No.
Why no?
Circuit
there is no path.
Absolutely correct. कारण मॅन्डेटरी कंडिशन काय, करंट फ्लो होण्यासाठी सर्किट मस्ट बी क्लोज्ड, आणि इथं ओपन झालेलं आहे. मग जर करंटच फ्लो झाला नाही पूर्ण सर्किट मधून, कॅन आय से दॅट आय इज इक्वल टू 0, म्हणजे यातून करंटच बाहेर पडणार नाही. मग इथं व्होल्टेज डेव्हलप होण्याचा प्रश्न येतो का? डेफिनेटली नो. मीन्स करंटच जर 0 असेल तर R1 च्या अक्रॉसचं व्होल्टेज डेव्हलप होणारच नाहीये, R2 तर नाहीच नाही, R3 च्या पण नाही, म्हणजे एंटायर सर्किट बिकम्स युजलेस. दिस इज द मीनिंग ऑफ दिस फर्स्ट लिमिटेशन. इफ अ ब्रेक ऑकर्स, आता मी इथं R2 मध्ये ब्रेक म्हणलेला आहे, तुम्ही R1 मध्ये ब्रेक कन्सिडर करा, R3 मध्ये ब्रेक कन्सिडर करा, किंवा या कनेक्टिंग वायर्स मध्ये वायर सुद्धा कधी कधी कट होऊ शकते, ओपन होऊ शकते. म्हणजे कुठं जरी सेरीज सर्किट मध्ये जर ओपन झालं, सेरीज सर्किट ओपन झालं, तर entire circuit, it becomes useless because no current will flow through that entire circuit. This is the first limitation of a series circuit is there. Is it clear?
Yes, sir.
Okay. Now let me remove this part is there. Now the second limitation is that different current rating devices or equipments cannot be connected in a series. आता डिफरंट करंट रेटिंग म्हणतोय मी. आता अजून एक एक्झाम्पल देतो बघा तुम्हाला. सपोज हा एक बल्ब आहे, डीसी बल्ब आहे, हा एक दुसरा बल्ब आहे आणि हा एक तिसरा बल्ब आहे आणि ते आपण कनेक्ट केले. हा ए म्हणू, हा बी म्हणू, हा सी म्हणू. ठीक आहे. ए बल्ब साठी लागणारा करंट 2 एम्पियर आहे, बी बल्ब साठी लागणारा करंट 4 एम्पियर आहे आणि सी बल्ब साठी लागणारा करंट हा 5 एम्पियर आहे. कॅन वी कनेक्ट these 3 bulbs in a series? Yes or no?
No.
Why no?
Current is different. Requirement will be different.
Absolutely correct. इथं बल्बची करंटची रिक्वायरमेंट वेगवेगळी आहे, पण आपल्याला काय माहित आहे सेरीज सर्किटची प्रॉपर्टी काय आहे? सेरीज सर्किट हा कुठला तरी एकच करंट सगळ्या बल्ब मधून फ्लो होईल. एक तर तो 2 एम्पियर तर 2 एम्पियर सगळ्यामधून फ्लो करेल किंवा 4 एम्पियर तर 4 एम्पियर, डिपेंड्स अपॉन द टोटल रेजिस्टन्स. करंट कॅन फ्लो थ्रू इट. इट मीन्स दॅट the different current rating devices or equipment we cannot connected in a series. म्हणजे आपल्या घरामध्ये जर बघितलं आपण तर फॅन साठी लागणारा करंट वेगळा आहे, टेलिव्हिजन साठी लागणारा करंट वेगळा आहे, फ्रीज साठी लागणारा करंट वेगळा आहे, ट्यूब साठी लागणारा करंट वेगळा आहे. दॅट्स वाय इन अवर or for domestic purpose all the appliances are connected in a parallel. म्हणजे हे जे सगळं घरामध्ये कनेक्ट केलेलं आहे, प्रत्येक गोष्ट ही पॅरलल मध्ये कनेक्ट केलेली आहे. ती कुठलीच गोष्ट ही सिरीज मध्ये नाहीये. जर तुम्ही असं अज्युम करा ए म्हणजे फॅन आहे, बी म्हणजे घरातली ट्यूब आहे आणि सी म्हणजे घरातला टेलिव्हिजन टीव्ही आहे, सी आहे. मग असं कन्सिडर करा की फॅन काहीतरी कारणास्तव बंद पडला, तर मग फॅन बंद पडला तर आपल्या घरातली ट्यूब बी बंद पडते का हो? टीव्ही पण बंद पडतो का हो? असं कधी होतं का?
No.
ऍब्सोल्युटली नो. कारण सेरीज सर्किट मध्ये एक जर पार्ट ओपन झाला तर सगळंच बंद पडते. जर ह्या घरातल्या सगळ्या वस्तू, हे सगळे अप्लायन्सेस, सगळे डिव्हाइसेस हे जर आपण सेरीज मध्ये कनेक्ट केलं बळजबरीनं, तर एक जरी पार्ट जर बंद पडला तर सगळेच पार्ट बंद होणार. आणि दुसरी सगळ्यात मोठा ड्रॉबॅक काय, जर आपल्याला फॅन बंद करायचा असेल तर सगळंच बंद होणार, टीव्ही पण बंद होणार, ट्यूब पण बंद होणार, सगळं घरातल्या सगळ्याच गोष्टी बंद होणार. का तर ते सिरीज मध्ये कनेक्ट केले आपण बळजबरीनं. ते तसं करत नाहीत कधीच. लेट मी क्लिअर दॅट. कारण त्यांची करंट रिक्वायरमेंट ही डिफरंट आहे. दिस इज द सेकंड लिमिटेशन ऑफ अ सिरीज सर्किट इज दॅट. अँड दॅट्स वाय वी नीड टू डिस्कस द पॅरलल डीसी सर्किट इज दॅट. Get it my point? So definitely it's my request to all the students, what the content we discussed about the series DC circuit in this lecture, please try to go through that in a detail. Think on it. Your thinking is very important on that concept is there, and try to clear that the more try to clear this doubt very strongly. If you have that the doubts related to the series circuit, definitely you can come up with this doubt in the next session is there, and in the next session we will try to discuss about the second part of a DC circuit, that is nothing but the parallel DC circuit is there. Okay, now let me try to note down that the attendance fast. Roll number 1.
Present, sir.
2.
Present, sir.
3.
Present, sir.
4.
Present, sir.
5.
Present, sir.
6.
Present, sir.
7. 7. 8.
Present, sir.
9.
Present, sir.
10.
Present, sir.
11.
Present, sir.
12. 12. 13.
Present, sir.
Present,
Four.
sir. 12.
Okay. 14.
Present, sir.
15.
Yes, sir.
16. 16. 17.
Present, sir.
18.
Present, sir.
19.
Present, sir.
20.
Present, sir.
21,
Present, sir.
22,
Yes, sir.
23,
Yes, sir.
24, 25,
Yes, sir.
26,
Yes, sir.
27,
Yes, sir.
28,
Yes, sir.
29,
Yes, sir.
30, 31,
Present, sir.
yes, 32,
Yes, sir.
33,
Present, sir.
33. 33 मला ऑब्झर्व झालं नाही.
33 present.
Yes. 34, 35,
Present, sir.
36,
Present, sir.
37,
Present, sir.
38, 39,
Present, sir.
40, yes, 41, yes,
Present,
not
sir.
42,
Present, sir.
43, 43, 44,
Present, sir.
45,
Present, sir.
46,
Present, sir.
47,
Present, sir.
48,
Present, sir.
49,
Yes, sir.
50,
Present, sir.
51, 52, 52, 53, 54, 55, 56, 56 is present. 57, 58,
Yes, sir.
59,
Yes, sir.
60, 61,
Yes, sir.
62,
Yes, sir.
63,
Yes, sir.
64, 64, 65,
Present, sir.
66, 67, 68,
Sir, 12 present.
yes, noted. Let me correct this.
23 present, sir.
20,
3.
23 is also noted.
53 present, sir.
53, okay, noted.
Sir, 52.
52 is also noted.
Sir, 56.
56 noted. Okay, thank you.
Sir, 41.
41 is also noted.